Good morning, everyone. I hope that we are doing great and I hope that you've been staying indoors and keeping everyone safe. So, today is going to be our first lesson online and it's going to be on section 15.1. This section, we're going to be learning about energy and its forms. So, in the book, they had a picture of the mountains and they're talking about how avalanches happen. And we can see in the picture up above, there's lots of snow in the mountain. It starts to pack, and then at some point, it has so much potential energy that that energy has to be released. And what is happening? So, what is happening is the snow is falling down. It's all the energy that the snow had from being packed up there upon layers, and it was potential, and now it's falling down, and it's because of energy. So let's jump into a little bit of the lesson. Energy. So energy is known by the changes it causes. Let's review back to the mountain that we were just talking about. How can we tell energy is going on? Well, you can hear it, right? When the avalanche is happening, you can hear all the rocks falling, the snow falling. And then you can see by the motion, you can see the snow actually falling. So, energy is very closely related to work. It is the ability to do work. Energy is transferred by forces moving an object through a distance. So let's talk about the example out of the book where we look at this backpacker. And they talk about you do work on a backpack by lifting it against the force of gravity. The work requires energy. The energy to do the work comes from your muscles. Your muscles receive energy from the food you eat. The energy contained in your food comes from plants that have used the energy of sunlight or animals that have eaten such plants. So we can see that there's all these different forms of energy. And as we can see that energy takes all these different forms, remember, energy is going to be measured in joules. So there's all these different forms of energy, but we're all going to be under joules. So when work is done on an object, energy is transferred to that object. And you can think about it with the book bag. As we lift that book bag, we are putting energy into that book bag. So we know that there are going to be two types of energy. The two different types of energy that we are going to talk about is kinetic energy and then potential energy. So kinetic energy is the energy of motion. So if we look at this picture of this person diving off the diving board, the kinetic energy is going to be him actually diving off of that diving board. Then we're going to see potential energy. The potential energy is him standing on top of that diving board. He's building up energy. Kinetic energy is what we're going to focus on first. So kinetic energy of any moving object is going to depend on its speed and motion. To calculate kinetic energy of an object, you have to multiply half by the object's mass, which is m, and then square its speed, which is going to be v. I want you to notice that if I had you double the mass, it would double the kinetic energy. If I have you doubling the speed, it's going to quadruple the kinetic energy because we can see that we have to square the speed. So that would quadruple the kinetic energy. All right, let's take the next couple of minutes and do some practice problems. What I want you to do at this point of the video is to read the practice problem, pause the video, and then come back and I will give you the answer. Let's review our first practice problem. So a 70-kilogram man is walking at a speed of 2 meters per second. What is his kinetic energy? So when we look at this problem, we know that we have the mass and we have the speed. All we have to do is plug it into our formula. Easiest way that I would do it is for half, I just plug in 0.5. So 0.5 times 70 times 2 squared. Your answer should be 140 joules. Okay, so our next practice problem, a 1,400 kilogram car is moving at a speed of 25 meters per second. How much kinetic energy does the car have? So we're looking at this problem. We know that we once again have a mass and we have a speed of the car. Once again, all we have to do is plug it right into the formula. As I said in the last practice problem, when I look at that half in the formula, I just put 0.5. Then you multiply 0.5 times 1,400 times 25 squared. Your answer for this problem, sorry, ESPN just went off on my phone. So your answer for this problem should be 437,500 joules. All right, so our next practice problem is going to be a zero point 0.1 kilogram bird is flying at a constant speed of 8 meters per second. What is the bird's kinetic energy? The bird's kinetic energy is going to be 3.2 joules. How I did that is I just plugged it once again into the formula. So I would do 0.5 times 0.10 times 8 squared. That is going to be the end of our practice problems. What I want you to do now is go into Documental in RunWeb and do the problems that I have listed there for you. Once again, go into the document section of RunWeb and there will be a worksheet there for you to do. I will give you the answers tomorrow. Good luck, my friends.